Okay, so in today's lesson 7.4, we are working with rational exponents. And rational exponents really just means fractional, okay? So we're dealing with exponents that have fractions in them. And I guess in saying that, if you're still struggling with working with fractions, please go back and review just simple things like when you have a fraction being multiplied by a fraction, right? So if you're looking at that and it's still unclear what to do, go back and just do some practice problems, learning how to multiply fractions. So in this case, just to answer for you, you'd be top by top, bottom by bottom, and this would give you 1 over 6. And then the other one that we'll be seeing is when we add fractions or subtract, right? But you get a common denominator. So in this case, 1 and 1/3 and 1/2 cannot be added. So you would need to then multiply this by 2, by 2, by 3, by 3. So that way you would get a common denominator of 6, which then you can add. So this would be 5, 6, okay? So again, if you need to review some of that, please go back and work on your fractions. All right, we're going to be learning about two different words really today, two different expressions that we say in math. All right, so the first one I already showed you was rational. So rational is just another way of saying fractional. A power with a rational exponent is equivalent to a radical. Okay, this is that second word. So what a radical is just another math term for just saying a root, okay? So we've seen these a bunch, when you think of like the quadratic expression and stuff like that. It's this one specifically is saying take the square root. So it's saying what two numbers multiply to give me that. So this would be 2, okay? But today's lesson is we're going to be looking at different types of roots that aren't the square root, that aren't root 2, okay? And actually just even in this first example right here. So if I give you a exponent, all right, an exponent that is a rational, well, what this means is you actually are taking the third root of 8. And that's because there is a 3 on the denominator. Whatever number is on the bottom here, you are taking the third root, or that root. So in general, if you have a rational exponent that is 1 over n, it indicates taking the nth root. Okay, but like, what does that even mean? What does something that is not a square root mean? Well, in this example I gave you here, because a square root is 2, you're asking yourself what two numbers multiply to give me 4. So in this question, it's 2. 2 times 2 gives you 4. Well, in this example that we did, I was asking you what 3 numbers multiplied to give you 8. So really, what you're doing is you're saying, okay, well, what 3 numbers multiply, what 3 identical numbers multiply to give me 8? And in this case, this would be 2. 2 times 2 times 2 gives you 8. So that's what it means when you take a root that is other than 2. It just means how many of this number multiply to give you what's on the inside here, okay? And how you evaluate this on your calculator, like let's say you didn't know this, all right? I'm just going to say this in general. Look for the button on your calculator that looks like this. It's a little triangle. And what you're going to be doing is you're actually going to be evaluating roots like this by using this exponent form like this. So you would say 8, and then this means to the power, and on your calculator you would type 1 divided by 3. Because you're essentially saying 8 to the power of 1/3. All right? So get used to using this. That's how you're going to be evaluating these types of roots. So there's 2 parts to the pie, though, all right, when it comes to rational exponents. And the thing is, when they are not 1, when the numerator of the rational exponent is not 1. And what I mean is, like, if this right here, this m, all right, so if we have something like 5 to the 4 over 3, not 1 over 3. In this previous example, this was 1 here, 1. But what happens if this is not 1 and it's something like 4? What do you do then? Well, we can see right here. what it's telling us to do is ignore the m for a second. It's still telling us to take the nth root, all right? So that's right here. But then, you see this m on the backside? It means take, in a bracket here, all to the power of m. So you would do this in stages on your calculator, okay? What you will do is you will evaluate this first. You'd be going b, hitting that button to the power, and you'd be saying 1 divided by n, okay? And you hit equals on your calculator, and you'll get some number, okay? And you usually have a button called answer. So you'll get an answer. The next step then says take that answer, all right, and then put it to the power of m, whatever m is. This is how you evaluate a rational exponent, okay? You have to do it in kind of stages here. So, for example, if I'm asking you to evaluate 4 to the 3 over 2, well, what you're going to do first, all right, this is equivalent to me saying the second root of 4, because there's a 2 here, and then you'd be putting that to the 3. So, what you need to do on your calculator is you need to go 4 to the power of 1/2, because you're taking the square root, okay? So you would get 2 if you did that. And then you'd be putting that to the power of 3. And then you do that next step, and you would get a final answer of 8. Okay? So you do it in stages. You do it in steps. Now, some roots of negative numbers do not have real solutions. But we know this. We've seen this before. We did this a lot in quadratics. When you have a negative number right here, and I'm asking you to take the square root of it, because that's what the exponent 1/2 means, right? So I'm asking you to take -4, the thing that's in the brackets, and then take the second root, so 2 here. Well, that is a square root. That is me saying what two numbers multiply to give me -4. And remember, these numbers need to be identical. So if I say 2, right? Well, that's +2 and +2. That does not give you a negative. And if I put negative and negative here, that would also give me a positive number. So you cannot take the square root of -4 or of a negative number. But in general, what n is, now we're getting beyond just square roots. If n is an even number, okay? Because if I have something like -4 to the 1/4, once again, I'm still asking you what 4 numbers, right? What 4 numbers would give me a negative number? It does not matter what you put there. If I put any combination of negatives or positives, right? This number would always end up positive. So the fact that I am asking you to evaluate a negative, you can't do it, okay? So you cannot take the root, an even root of a negative number. However, you can do it for an odd number. And why? Well, that's because when you have an odd number here, I'm asking you to evaluate the third root of a negative. And really what that's me saying is, okay, well, take what 3 numbers will give you a negative number. And it doesn't matter, again, right? Like when you're putting the 3 numbers here and you're multiplying them, when you put negative, negative, and negative, these two will give you a positive number. But then a positive times a negative gives you negative. So in this case, when you take the third root of -8, you're actually going to get -2. That's because -2 times -2 times -2, all right, these first ones will give you +4, but then +4 times -2 gives you -8, okay? So we have multiple different types of, and these are called radicals, okay? That's what a root is. A root is a radical. There are odd radicals and even radicals. So when you have an even one and it's a negative number on here, can't do it. When it's an odd one, you can, all right? So it's always be on the lookout for that. So in this case, your final answer was -2. All right, so we're just going to be going back and forth between radical, all right, and then going from radical to rational exponent form. So in this first one, I'm asking you to go to radical form, okay? So I'm asking you to put it into the root form. And then we actually want to practice evaluating. So while I'm doing this, because again, a lot of this is really just you understanding how to put it into your calculator, right? So if you're just following along, maybe pause the video, all right? Try it out for yourself, and then see if you get the same answer as me. Okay, so in the first one here, let's do it. 16 to the 1/2. Well, I'm asking you to take the second root of 16. So you're putting this in radical form. Well, it's the base 16 put under the square root. Okay? So again, so that's how you write it. That is radical form. But now if you want to evaluate, all right? Well, to evaluate this on your calculator, I mean, yes, this is a square root, so you can just hit your square root button. But if you just want practice using the rational exponent form, take 16 and put it to the power of 1 divided by 2. And you will get 4, okay? Just like if you took the square root of 16, you would get 4. So this next one, 16 to the power of 0.75. Well, this is a decimal. We don't want decimals. We want fractions. Well, 0.75 is 3/4. So 16 to the power of 3/4, well, how do we evaluate that? Put this first in radical form, okay? Well, that's actually what the question is asking. So put it in radical form. So 4th root of 16, because this is a 4 here, and then to the power of 3. So on your calculator, this is how you want to visualize this way. You're going to go 16 to the power of 1 divided by 4, all right? That's going to give you what this all equals. You'll get your answer. After that, you put it to the power of 3. So 16 to the power of 1 divided by 4, well, that's 2. And then you take 2 and you put it to the power of 3. That's going to give you 8. So your final answer is 8. C, -2 to the power of 1/2. Well, that's me asking you to take the second root of a negative number. But this is no solution. And that's because this is an even number. If this is even and this is negative, you can't do it. Okay? D, well, put this in fraction. This is the same thing as me saying -4 1/2. All right, well, you might be thinking, well, this is negative again, and that's even. Can't do this. But no, fundamentally, these are different. Notice brackets, no brackets, okay? So really, this is like me saying -1 times 4 to the 1/2. So that's -1 times the second root of 4, which would be -1 times 2 or -2. Okay, notice brackets. It completely changes the question, all right? So you have to be good with your BEDMAS and understanding brackets and when multiplying and exponents here, okay? So you apply, and so I mean by when I say BEDMAS. Technically, you deal with the exponent before you deal with multiplication. So we deal with the exponent before we deal with the multiplication, all right? And that's why your answer is actually a solution. So example 2, write in exponential form, then evaluate. Okay, so I see a 3 here. What that means is I'm taking whatever's in the bracket here, or under the root, sorry. And I'm saying 64, and that is to the power of 1 over 3, because there's really a 1 here, right? I don't see a number, so that number is 1. So now evaluate this. So try it out for yourself. Go 64. I'll write it over here. Don't write the purple, okay? Because this is me just showing you how to practice your calculator. Go 64 to the power of 1 divided by 3, all right? And if you do that, you will get 4. All right, so next one. 25, and that 25 is being put to the power of 3, and it is under the second root. So my base is 25. That's the number you see here. It's the second root, so that means my denominator needs to be 2. And I'm putting it to the power of 3. Cool. I wrote it in exponential form. Now how do you evaluate? Well, I want you to first do the square root, okay? Or this. It actually does not matter which one you do, but just do them in steps, okay? So go 25, put to the power of 1 divided by 2. Get that answer, and then you're going to put it to the 3. So that is 25 to the power of 1 divided by 2, so essentially taking the square root of 25. You will get 5. Put to the power of 3, you're going to get 125. And this is an example why you might want to do it the way I'm showing you, doing it in steps, okay? Because if you, well, first let's put it in exponential form and I'll show you. So this is negative 81, right? Our base is negative 81, and it's being taking the third root of it, so that means your denominator is 3, and you're putting it to the power of 2. So up here is 2, okay? So that's in a bracket like this. Now if you took your calculator and you went negative 81 to the power of 2 divided by 3, you're actually going to get an error. And why you get an error, outside the scope of this course. But this actually has a solution, and this is why it's important to do it in steps, okay? So do it in steps. Go negative 81. First, evaluate your root, okay? So you're going to go negative 81 to the power of 1 divided by 3, all right? Get your answer. Then take that answer and put that to the power of 2. And if I do it on my calculator, I know this isn't going to be a nice number, so let me just do it. 81 to the power of 1 divided by 3. And then I square that answer. Oh, so my calculator did something weird. So, sorry. 81 to the power of 1 divided by 3, I get negative 4.32, and then I square that answer. So you get 18.72, okay? So if you did it like this, you would have got an error, but that's not true. It's actually 18.72. So let's try it again. So in this one right here, let's put it as a exponent first. So let's rewrite it. So technically, this is me saying 32 in brackets. And I'm taking the fifth root, so that's like 1 over 5, all to the power of negative 1. All right, well, what does a power to a power do? Well, you need to multiply these. So this is 32 to the negative 1/5. So at this point, take your calculator, go 32 to the power of negative 1 divided by 5. Or you can think of it this way too. You can go negative first, so 1 over 32 to the power of 1/5, right? Deal with the negative first. Either way, you will get 1/2 when you evaluate it. If you didn't, check your calculator, okay? Make sure you're doing it properly. So simplify, then evaluate. So in this problem, it's not telling us exactly to either work in rationals, radicals, or anything. It just means simplify. So simplify just means use whatever exponent laws you want to use to get it to its lowest form, okay, and evaluate it. And that will probably mean a lot more to you when we start getting to things like this, okay? These first couple ones that we're going to do don't really require that much simplifying. So in this first one here, simplify, then evaluate. Well, we really don't have to simplify anything because it's already as simple as it can be. You have a base and you have an exponent. That's as simple as it can be. So now it's just evaluate. So do it in steps. You are going to first evaluate 9. Like again, this is actually like you saying the square root of 9 to the power of 3. So do this portion first. So go 9 to the power of 1 divided by 2. Get your answer there. So, and then put that to the power of 3. So square root of 9 is 3. Then put that to the third. That's going to be 27. Let's do it again here. B. It's as simple as it can be. You just have a base and you have an exponent. So deal with each one of these in steps, all right? So we are taking the third root of negative 64. So that means me taking negative 64, right? I'll write it out what this is equivalent of saying. Negative 64 squared. So you're dealing with this first. So go negative 64 to the power of 1 divided by 3. All right, well, the third root of 64 is going to be minus 4. Then square that answer. All right, so all of this would have been squared. So that would be 64. Oh, sorry, 16. Jeez. 16. Okay, 25 over 4 to the power of negative 3 over 2. So let us see. Well, I'm going to deal with my negative first here, okay? So that negative tells me take my fraction here and flip it. So now it becomes 4 over 25 to the power of, and again, all you did was get rid of this negative. So it's still the same exponent. It's still 3 over 2. Now the rule says take this exponent and distribute it to both numbers because you have a fraction. So it's using the laws we learned before. So this is 4 to the 3 over 2. This is 25 to the 3 over 2. So you are, in essence, taking the second root, because there's a 2 here, of both, second root of 4 to the third. And on the bottom, you are taking the second root of 25 and putting it to the third. So what is the square root of 4? That's 2, right? What is the square root of 25? 5. Put that to the 3. So your final answer will be 8 over 125. Okay? You don't have to use your calculator every single time. If you can, you just do the square roots in your head. But if not, do this. Okay? So let's keep going. 25 to the 1/2 minus 81 to the 3/4. Okay, so rewriting this, simplifying it. Well, 25 to the 1/2, essentially, that's like me taking the square root of 25, and then I am taking the fourth root of 81 and putting this one to the 3. So square root of 25, that's 5. What 4 numbers multiply to give me 81? That's 3. And then I put that to the third. So then I get 5 minus, well, 3 to the 3 is 27, or negative 22. E. Okay, so I have 12 put to the power of negative 2/3. Then that's put to the power of 1/2. Then all of that is put to the power of negative 3. This may look complicated, but really it's just working within your brackets. So like think about starting here, okay? So think about this being your only question. So what I'm asking you to do is go 12 to the negative 2/3, and that is put to the 1/2. So what would you have done? Well, you have to multiply your exponents. So that becomes 12 to the minus 2 over 6. Okay, so you dealt with that. But remember, all of that was actually put to the power of negative 3. So that means this answer has to also be put to the power of negative 3. I'm going to give myself some room here. Oh, okay, I'll just rewrite it then. $12 to the minus 2 over 6, all over to the minus 3. Okay, so now, once again, power to a power. So you multiply this by minus 3. So what is 12 to 6 times 3? Well, you multiply your numerators. So that would be 18. So, negative 2 times 3 is actually 6. Well, I don't know why I said 18. Negative 2 times 3 is 6 over 6. And then you get 12 to the 1, or just 12. Write each expression as a single power with positive exponents. Okay, so key thing, single power, what that means is like just some base put to some power, okay? And that power, this specifically, this x, needs to be positive, okay? So if you have b to the negative x, you have to answer it as 1 over b dx, okay? I want a positive answer. So this is where that fraction work I was telling you about, all right? So let's look at this. We can clearly see we have a bunch of 8s here, all right? So there's our common base. So we're going to have to use all our exponent laws. So let's do this in steps. 8 to the 5/6 multiplied by 8. Let's rewrite this as a fraction. So that is 8 to the 1/2 because you don't see a number there. So that number is actually 2, okay? That's like a normal square root. All of that is then being divided by 8 to the 5/3. So let's clean up our numerator here, okay? So those are the same bases being multiplied. So I can add my exponents. That's 8, 5, 6 plus 1/2 all over 8 to the 5/3 still. Okay, 5, 6 plus 1/2. Again, get your common denominator. So again, these would have to be multiplied by 3. All right, so you'd have 3 plus 5, so 8, 6 up top, all divided by 8, 5/3. Now subtract exponents because you have 8 bases, similar bases being divided, so you subtract. So that's 8 and 8, 6, all right, minus 5/3. Well, actually 8, 6, you can really reduce this. This is the same thing as you saying 4/3. So this is actually 4/3. And look at that. You have same denominator, so you don't have to do any more fraction work. Okay? 8 to the 4/3, well, that is 8 to the negative 1/3. Now we have it as a single power, but our exponent is negative. So this is actually 1 over 8 to the 1/3. Okay? So careful with your fractions, because you have a fraction that has a fractional exponent. B, 25 to the power of 1.5 times 25 to the negative 2, and that is put to the power of, oh, there's a spacing issue here, but that's to the power of 3/4. So first, let's write 1.5 as a fraction, okay? So 1.5 is the same as 3 over 2. So in that first bracket there, we have 25 to the 3 over 2, and that is being multiplied by 25 to the negative 2, and that is being put to the power of 3 over 4. Okay, so we have a power to a power. So deal with that. This is 25 to the 3 over 2, and then that bracket is 25, negative 2 times 3/4. Well, that's going to give you minus 6 over 4. Well, let's reduce this right here. That is the same thing as me saying 25 to the 3/2, and then 25 to the, well, negative 6 over 4 is the same thing as me saying negative 3/2 when you reduce that. Now we have similar bases being multiplied, so we can add our exponents. 25 to the 3 over 2 plus minus 3 over 2. So that's 25 to the 3 over 2 minus 3 over 2. That gives us 25 to the 0, or anything to the 0 gives you 1. All right, so final answer there is 1. Simplify, write each answer with positive exponents. So again, use whatever rules you want to use to simplify this, all right? And at any point here, just pause the video and try it out for yourself. These are harder questions, all right? So give it a shot yourself. And just in saying that, when you try yourself, there's no right approach, okay? So like the approach I'm about to take is not necessarily the right approach because there's multiple ways to go about solving this problem. Okay, so what I'm going to do is I'm actually going to clean up everything I see in the bracket here. So I have things up top multiplying and things on the bottom multiplying. So let me clean up those. So this is going to be equal to, and right now I'm just going to pretty much ignore this up top here, all right? So inside I have x to the 1/2, and that's being multiplied by x to the -2. So really I'm just actually adding my exponents up top there. And on the bottom, same thing. I have x to the -3, and that's being multiplied. That's what these brackets mean here. So I'm going to be adding, also on the bottom, 2/3. And yes, I'm ignoring this for now, but it's still there. It's still -3/2 up top. Okay, so this is what I mean. Work with your fractions here, okay? So up top, inside of our numerator here, we have 1/2 plus -2. So that's technically saying -1/2 minus 2. So up top, you're going to get x, and then it'd be 1/2 minus 4/2 after you get a common denominator. On the bottom, this is going to be, when you get a common denominator, minus 9/3. So that's a 9 plus 2/3. All still to the 3/2. So we have x to the minus 3/2 up top. And then we have, on the bottom, x to the minus 7/3. All to the 3/2 still. Now I'm going to deal with inside the bracket still, but these are dividing. So I'm actually going to be subtracting my exponents. So inside now I have x minus 3/2, and I'm going to be taking away minus 7/3, all still to the 3/2. So this is x minus 3/2 plus 7/3. So you're going to need to get a common denominator, minus 3/2. Okay, so times this by 3, by 3, by 2, by 2, right? So that's x to the minus 9/6 plus 14/6, all to the minus 3/2. So a lot of steps here, okay? Very easy to make a mistake. Equals, well, -9 plus 14, that's x, and that's going to be 5/6 to the -3/2. Now multiply your exponents because you have a power to a power, so I'm now finally going to be dealing with that outside. So that's, well, I don't need the bracket anymore. X, and then multiplying your fractions, minus 15/12. So your final answer, because now we have it as a base to an exponent, but we just need to get rid of that negative. So that's 1/x to the 15/12. Okay, just 1 because you deal with the negative. Last question, B. So we have a to the 6 to the half, a to the -4 to the -3/2. So what I'm going to do is I'm going to say, well, I'm going to deal with these powers to a power here, like that. So in the first bracket here, I have a to the 6 to the 1/2. So that's a to the 6/2. And that's being multiplied by a to the -4 to the -3. So I multiply that -4 and that -3, I would get 12/2. So that is a to the 3 after you reduce 6 and 2, multiplying a to the 6 after you reduce 12/2, and then you get a to the 3 plus 6 because you're multiplying similar bases, so add exponents, and finally you get a to the 9. And that is a positive exponent. Oh, yeah, and that's right, sorry, I thought I made a mistake with my negative. Yep, that's your final answer. So there we go. This takes a lot of work, very easy to make a mistake, so we'll do those practice problems in class together. All right, bye for now.